So when you release, it will go this way, right? This block is 2 kilograms, and the whole system is frictionless. And then this spring is 100 Newton per meter. The block is released from rest, and the plate is frictionless. Okay. The question is, what's the speed of the block when you move to here, for example? From here to here, it's 0.2 meter. So we need to analyze according to the energy. At the beginning, move from here to here, you need to calculate the height change, right? So at the beginning, it only have a potential energy. You can determine that by the height. And it will be mgh, right? And then this energy will convert into the energy in the spring. And the kinetic energy of this block, right? The energy in the spring will be 1/2 kx squared, right? And the kinetic is 1/2 mv squared. Okay. And then let's calculate mg times h will be 0.2 times sine 37 degree. And k is equal to 100. X is 0.2. So if it moves 0.2 here, the spring needs to move 0.2, right? The extension. So it's 0.2 squared. Then plus 1/2 2 kilograms v squared. So everything here, you know, the only variable is this v, right? If you calculate v equal to 0.6 meter per second, which is 60 centimeter per second. So it's C, this question.
The only thing I'm not getting is the MGH.
MGH. You don't get here?
Yeah.
So that's a surface, right? It's 37 degrees.
Okay, I get it.
You got it.
Mm-hmm.
So it goes,
Because it's going down, it's MG
Yeah.
sine of the angle.
So if it's go down 0.2, you need to calculate here, right? So it's
I get it.
yeah. The distance times sine 37. Then we'll go to the first question. So the first one is, it's all about potential energy. A single conservative force. Do you understand the concept about conservative force?
Mm-hmm.
So the work is done, it will convert into potential energy.
Right.
Right? And then this conservative force, like the gravity, is conservative, right?
And the spring.
Yeah. Newton. particle moving along x. So it's one direction. And the potential energy associated with this force is assigned to a value.
So it'll be the negative derivative, integral.
Yeah, the anti.
Because the x and flow was the potential energy between.
So first you need, we know the potential energy at 0 is 20. And they ask you the potential energy here. What you need to do is to see how much work is did, right? So it's it will be from 0 to 3 fx dx, right? That will be 3x squared minus 12x, 0 to 3. 0 will be 0, so 3 if you calculate times 3 squared times 3. So 27, 36, negative 9. So the work by the force is negative,
Right.
which will convert into positive potential energy, right? So P3 will be P0 minus the work divided by will be 29. This question. Okay. So you don't have any problem.
Because it's you did the work, it would be the initial minus the final.
The initial minus the work divided by the
So
force.
it's the initial potential minus the work.
Yes.
Okay.
Yes.
So it will always be positive.
If you consider it as this is a spring, for example, it moves from 0 to 3. So in this process, this force is negative, right? Because it's pulling back. But it's conservative because the energy is stored in the spring.
Okay.
But the work it did is negative, right? If it moved from here to here. But this negative work, for example, negative 9, will convert into 9 in the potential energy, right? So you just need